Hey, this is Scott again. So I wanted to do a quick recording to follow up on the last one I did on time series. I did a brief introduction to time series analysis and forecasting last time, and so I'm just following up with a few additional things. So our agenda, if hopefully you can see my screen. So let's review the what we did last time, part one, and then we're going to go into the no free lunch theorem, which I'm a big fan of, and then we're going to look at some ways to approach time series, just to let you know some of the things that are out there. Not that we're going to go in any detail really. I'm going to give you some references, some things that you can look at, places to go for using traditional time series univariate analysis, and then I'll give you some ideas for correlated predictor variables to predict the time series, so you can forecast the series using other predictors other than the historical forecast itself. And then a couple of platforms that you can do time series in, including R and Python, a couple of libraries there, and then see if you want to go anywhere with me the next time. So reviewing what we talked about last time, so we talked about what is time series and and forecasting and what's the difference between the two. We talked about some time series examples, basic steps, components of time series, way to approach time series at a high level, even briefer than this one, and then some playlist resources from my channel and some stuff that I have, especially in R, that addresses some examples of doing time series in R, and then what we're going to cover today, which we're going to get into now. So again, this is the things that we're going to talk about. So with that, let me really kind of jump into it. So the first thing I want to talk about is this no free lunch theorem. It actually is in computer science, but it applies to machine learning and data science. So you know, we often hear about, you know, the killer algorithm, or the, you know, this approach solves everything and this is, you know, great, and everybody's looking for, you know, the computer to do all the work for them, quite honestly, is the way I see it. And that's really not a good way to go about things. In fact, it fails often. And it fails because each data set is different, each problem is different. And so I always use the analogy, you don't want one tool in your toolbox, right? So you don't want just a screwdriver, and because screwdrivers only solve very few problems. And you know, there's literally dozens of different kinds of screwdrivers. There's a 6-point screwdriver, a flathead, Phillips screwdriver. There's tons of even screwdrivers, and then certainly there's a lot more other tools that you might need: pliers, wrenches, hammers, chisels, etc. So I view the data science AI toolbox to be one that you need a lot of different tools in to solve a variety of different problems, and that will help you in your career, the way I see it personally. I do hear people talk about the killer algorithm. You know, everything was deep learning for a while. Deep learning solved everything, and deep learning is good, but there's problems with it too. There's pretty much a trade-off to anything that you do along any analytic process. So and you will probably have a go-to method that you start with. A lot of people, you know, have kind of their fallback, but you really should have a lot of different tools in your toolbox, is my suggestion. So if you really look at time series in two broad aggregate ways, one way is to use the univariate series, right? Or you don't even have to use just the univariate. You can use a multivariate series in time. But the first set of methods is essentially using just the historical pattern of the variables that you're going to predict and learn how they are moving through time, and then you mathematically create a model based upon that movement to forecast the future, right? So that's one way to go about it. And so there are things like decomposition, which I think I have a slide just to tell you a little bit about what I mean by that. And then there's all these basic methods like naive and seasonal naive and drift methods, and then you kind of get into the more historically algorithms that, things like autoregressive, moving average, ARIMA models, which is a combination integrated autoregressive integrated moving average, and then seasonal, ARIMA, GARSH, some of the other techniques. But the idea on every single one of these is you are using the data itself historically to predict the data itself in the future. Let's contrast that to another way of looking at it, which is essentially if I have correlated variables to the series and I can get future values of that more easily than I could get my current values, then I might be able to use those to predict the future as well, right? So instead of using just the historical pattern of the variables I want to predict themselves, I actually am using correlated variables, adjunct variables to do that. So those are two very broad categories. So one way to look at, one way to do this, very simple method is decomposition. So I can break down the series into seasonal components like hours of the day, days of the week, week number, month, and then if you're familiar with like linear models, right, I can actually create linear models from those different components, right? So if I'm doing retail, I'm going to have a day of the week that I probably score very high on, maybe seasonal patterns throughout the years, maybe fall is really big time, or maybe certain months are a big time. But I can even create forecast in something as simple as Excel with something like that. So I break the components down, the time series components, and then I use those components kind of in a linear fashion, kind of a weighted fashion to predict the future. And then, and I can even do that piecewise linear as well, right? So I could break the components down into, the patterns from 2000 to 2005, and look at the growth rates, and I can see that those growth rates are slowing. So from say 2016 to 2020, I see these things dropping at 3%. Maybe that's only going to be 6% piecewise linear as well. So hopefully you get the idea of what I'm trying to say there. So just a really good text for using the traditional series is Hyman. He's got a book that's available online. You can see there, otext.com. He's had 3 different versions. He's currently in his 3rd version, FPP3, and he has the associated R code that goes along with this. So this is the one that I use for the data science course, Masters in Data Science at CUNY. The one that I use there, and I've used it for several years now, and it's been really good. And then of course he's updating it, and then there's some videos out there as well, so lots of good resources. If you're looking at using the correlated or predictor variables, you can see there, neural nets actually work pretty well. Convolutional neural nets, which is more of a deep learning pattern, just basically deeper neural nets. They work pretty well. And then I just mentioned one of the piecewise models, but a method that that I like to use as part of my toolbox, one of my go-tos, is MARS, multivariate adaptive regression spline. Actually, I find those very powerful. I'm surprised they're not used more. And then there's other methods as well. There's lots that you can certainly research. And so I just wanted to throw out some of the ways to evaluate your forecast accuracy. The one that I probably use most often, at least for my coursework and everything, is the third one, the MAPE, mean absolute percent error. So that one, it tends to work well. But Hyman, he'll talk about all of these different methods. And quickly, some places that you can do time series with, right? So Excel, again, you can do some decent time series with Excel. Again, I tend to think that, you know, there's no one way to go about this stuff. Having a lot of even platforms in your toolbox is really good. There's a lot of commercial companies like SAS, IBM Modeler, Domino, Data.IQ, 9, AWS, Microsoft Azure. So there's tons of commercial packages out there as well. If you want to go open source, certainly you can do R. There's development tools there like RStudio and others. And again, that's what Hyman's using. And I'm referencing the old FPP2 here, but he's got the new book out there as well. And then ggplot, that's really good. And then Fable is another one in R. And then the profit package, which Facebook uses a lot, is available in R. It's also available in Python. So if you prefer to do your data science open source in Python, and you can use different IDEs for that, like Jupyter and Spider and some of the other ones. Profit's available there, as well as NumPy. And there's a lot of others. I'm not certainly familiar with every single one. And then finally, if you want to see me do more videos like this on time series, let me know. You know, there's only so many hours in the day. I'm thinking about doing some more, as far as my channel goes, on Python. But time series could be something that I focus in on, or I could focus in on other machine learning methods or just general coding there, or even just at a higher level, you know, some of the books that we've written on you know, the right infrastructure and everything for data science. So if you want to provide feedback, please leave them in the comment of this video. Appreciate it. Thank you very much.